Okay, now we're moving on to areas, surface areas and volume. And these are other things that you need to be able to deal with without any information given to you. So in order to find the volume of a cuboid, and a cuboid is just a rectangular block, then you're going to multiply your length by your depth by your height. So the volume is going to be 6.4 times 4.8 times 3.5. Okay, so we've got 6.4 times 4.8 times 3.5, 107.52. And again, clearly stating the units of your answer. Well, length is centimeters, area is centimeters squared, volume is centimeters cubed. So you want cm with a little 3 above it. Now, to work out the surface area, what that means is if we were to cut that cuboid up so we could lay it out flat, what would be the total area that that would cover? And the way you do that is you work out the area of each flat part, or each surface part of the cuboid. So you can see here that the front is going to be 6.4 by 3.5. But we haven't just got one front, because that exact rectangle is also at the back of the cuboid as well. So we have two of those faces. So we've got two 6.4 times 3.5. Short, isn't it? 2 times 6.4 times 3.5. So we've got 44.8 would be the area of the front and the back. Now similarly, we've got a rectangle that's the top of this and an identical one which is underneath. So the area of the top of that, well, it's going to be 6.4 centimeters long, and it's going to be 4.8 centimeters deep. So that rectangle on top, and there'll be two of them, one for the top, one for the bottom, will be 6.4 times 4.8. Okay, so we do 2 times 6.4 times 4.8, 61.44. And then we've got two ends. We've got this end here, which is going to be 4.8 times 3.5 for its area, and an identical one coming in that side. So we've got to have two lots of 4.8 times 3.5. So 2 times 4.8 times 3.5. 33.6. So the total surface area of that cuboid we get by adding up the areas of each sides of the shape. So it's going to be those three figures added together. So we have a surface area of 139.84, and the units for area are centimeters squared. So that's that one done. Now we're moving on to this shape, and we need to find the volume of it, and as it says there, this is a triangular prism. Well, if we go back to the front sheet in our exam paper, this is the second formula that we're given. Volume of a prism is the area of a cross section times the length. Now a cross section of a prism means that if you get a knife and you slice this shape, the area that you get from the cut is the cross section. And for it to be a prism, that has to be identical no matter where you cut the shape. So that tells us that what I need to do here is calculate the area of the cross section, which is a triangle. Area of a triangle we know is half base times height. So area of cross section will be half times 40 times 50. Okay, so let's just do that now then. So we got half times 40 times 50 equals. So that's going to be 1000. Now that's an area, so it's going to be centimeters squared. So to find the volume, we need to multiply the area of cross section. Just go back here. Okay, area of cross section is what we just worked out, times the length of the prism that we're finding the volume of. So the area of the cross section is 1000, and now we're going to multiply that by the length. But we have to be very careful here because the length is given in meters, not centimeters. We want our volume in centimeters cubed, so we have to turn that into centimeters before multiplying. We should know there's 100 centimeters in a meter, so 1.2 meters is going to be 120 centimeters. So in order to work out the volume, that's what we need to multiply by. So we do 1000 times 120 and we get 120,000. And the units for volume, centimeters cubed. Okay, so you need to be careful when you're working with volumes that all the units are the same, all the sides are the same units in measurement before you multiply. Okay, the last volume question that I've come across is this one. It starts off a bit different because we have to draw a three-dimensional cuboid of dimensions 4 centimeters by 4 centimeters. They've given us some triangular dotty paper with which to do that, and the way that triangular dotty paper works is that the gap between each pair of dots is 1 centimeter. So there's lots of different ways that you can do this. 4 centimeters by 3 centimeters by 2 centimeters. I'm going to make it 2 deep. So that's going to be the depth of the height. Then I'm going to go 4 this way. 1, 2, 3, 4. And 3 this way. 1, 2, 3. And that will create three-dimensional cuboid shape. 1, 2, 3, 1, 2, 3, 4. Okay, so from a different starting point, you could have had that standing up, you could have had the 4 centimeters going that way and the 3 that way. It really doesn't matter. The key thing is that you're aware that the distance between each dot there is 1 centimeter. So I have 3 centimeters there, I have 2 centimeters there, and I've got my 4 centimeters like that. And then part B, a water tank is the shape of a cuboid with a base of length 30 and width 20, and we want to find the depth of the water when 9,000 centimeter cubed of water is poured into the tank. So this is a bit more tricky again because this is telling us what the volume is. Now we know that the volume is length times width times height, which is what we were working with previously. So if I put into that what I know that the volume is 9,000, the length is 30, the width is 20, and I want to find out what the height or the depth is. Okay, I can work out what 30 times 20 is, 600 times the height. So just like an equation now, I want to get that h on its own, so I've got to undo a times by 600 by doing the opposite. The opposite of timesing by 600 is dividing by 600. So if I do 9,000 divided by 600, I get h. So h is going to be 9,000 divided by 600, 15 centimeters deep. Okay, so that's volumes, areas and surface areas, as well as drawing them three-dimensionally.